Hello everyone, here is Yuanhui and today I will go over homework 7, question 8. According to question 8, it says a Poisson process is defined by follow probabilities. There gives three statements. First, the number and integral t of the point t is the integral of t1 and t2 of length t equal to t2 minus t1. It's a Poisson random variable with parameter lambda t. And second is, if the integral t1, t2, and t3, t4 are non-overlapping, then the random variable n t1, t2, and n t3, t4 are independent. Statement 3 is at a time moment t. There is no more one Poisson point. Using the point t1, we form the stochastic process xt equal to n integral 0 to t. So it's asking us to find the exact value for xt. In here, by using the first statement and remove the t, we can get a probability of x equal to k was e powered by negative lambda and times lambda power of k divided by and from infinity to k equal to 0, the e power of negative lambda is lambda k divided by k and equal to 1. And flip that over to here and we can get the formula equal to e power of lambda. And for both sides, divide by the lambda k, power of k divided by k equal to e power of lambda. But after this step, we can get which is the k times lambda power of k divided by k times e power of negative lambda equal to lambda. So from that we can get expected value of x is equal to lambda and also equal to from infinity to k equal to 0 and k times e power of negative lambda times of lambda power of k divided by k. So from that we can get expect value of xt is equal to lambda times t. And in the second question is asking us to get the r integral t1 to t2. So from the problem 1 we already get from infinity to k equal to 0, the k times lambda k divided by k equal to lambda e power of lambda, and derivative by the lambda from both sides, we can get this formula, which is the left side lambda times 1 plus lambda equal to expect value of x squared, x times 2. So for when the t2 larger than t1, the r integral t1, t2, t2, it's from the expect value we separate it into two parts. Expect value of xt1 times xt2, and separate it again. xt1 times xt2 minus xt1 plus xt1. By using the partition process, we took the expect value away, and we finally get x lambda t1 times lambda t2 plus lambda t1, which is lambda times t1 plus lambda t1 t2. It's a final value for our interval of t1 t2, and when t1 larger and equal to t1, it's similar, but in here the outside is lambda times t2. Is the previous step is lambda times t1, and in this step is lambda times t2, and finally we can get pretty similar, but the first one is t2 right here. So the R interval of t1 and t2 is equal to lambda times mean interval t1 to t2 and plus lambda t1 times t2. That's the final answer for question number 8, problem B.